Okay. Do you have any questions? They're very simple. So I usually have the office hours for 12 to 1:30. So there is a link in Moodle, so you can always connect if you want. Every day, so Monday to Friday, one from 12 to 12 something, 1 or 1:30. Or you can also make an appointment. So either way, so if you have any issues, you can always let me know. Okay, any questions? Now let's come to chapter 3. And we're going to start from 3.1. How should we graph the function? Or how should we graph the linear equation? How should we graph the linear? Let's start from the definition here. So 3.1. Actually, this one is 3.1b. Graphing the linear equation with intercepts. So definition. Any point that has x or y coordinates. Any point that has x or y coordinate of 0 is called the intercept. Any point that has x or y coordinates of 0 is called the intercept of the graph of the equation of the graph of the equation. Because it is at these points that the graph intersects the x or the y intercept. X or y axis. X. So say points that has x or y coordinates. At these points that intersect the x or the y axis. So we have two intercepts. So we have the x-intercept, then we have the y-intercept. So for the x-intercept, That is a point where y is equals to 0. And then for the y-intercept, that is a point where the x is equals to 0. Okay, now let's do another definition. So let's say this is 1, this is number 2. X-intercept. X-intercept. So what is x-intercept? If x0, and that one is a coordinate, if x0 is a coordinate, this is now the point where y is equals to 0. If x0 satisfies an equation, then the point x0 is called x-intercept. The point x0 is called x. As you can see, so x can be any value, any real number. So, and apart from 0, okay? So, and y is 0, so that means that one will be the x-intercept. Number 3, y-intercept. Y-intercept. If 0y, if 0y satisfies the equation then the point 0y is called the what? Y-intercept. It's called the y-intercept. This is now the point that x is equal to 0. The y-intercept. Now, to find the x-intercept, what do? To find the x-intercept, we let y to be equals to what? 0. If we have the equation, then to find the x-intercept, we let y to be equals to 0. To find the y-intercept, we let x to be equals to what? 0. Let x to be equals to 0. Let x to be 0. And this one, let y to be 0. Now, before you plot, so these are the points which you can use now to plot the line. That's very nice. Linear is something straight. Okay. So if you have a linear equation, then first of all, what you need to do is look for the x-intercept. You look for the y-intercept. And then also you can still look for another point. You can still look for another point. Or you can still use this one to draw one. So you can either look for this point and this one and any other point. So you can choose. So we'll see an example of how we can graph the linear equation with the intercepts. Example. Graph minus x plus 2y equals to 6 using the intercepts. Graph the points. Those ones using the intercept. So how will you graph this? So how should we get the intercept? So solution. So first of all, we look for the what? X-intercept. We look for the X-intercept. So our equation is minus X plus 2y equals to 6. Okay. So what is our X-intercept? So you let y to be equals to what? 0. So when you let y to be equals to 0 here, what will be x? So our x equals to minus 6. What is our coordinate here? Our coordinate will be -6, 0. So that is our point. That is 1 point. Then number 2, we get the what? The y-intercept, where we let x to be equals to 0. So when you let x to be equals to 0 in this equation, then it will be 0 plus 2y equals to 6. So our y equals to 3. What is our coordinate there? 0 and 1 and 3. So we have the 2 points. So we can use the 2 points to draw the straight line, or we can still look for another point. We can basically use the 2 points to get a straight line. Or we can also look for another point for accuracy. It doesn't matter. You can either use these points or you can still look for another point. So how can we look for another point? So if we have this minus plus 2y equals to 6, how can we get the other point? Yeah, so you can plug in any number, right? So you can just plug in, you can let x to be equals to, you can put x to be equals to 2 here. Or you can put x to be equals to 1. Okay. So when you let x to be equals to 1, then we come and put this, we substitute here. So we get minus 1 plus 2y equals to 6, right? So when you take this one to the other side, so 2y equals to 6 plus 1. So y equals to 7 over what? Over 2. And our other point will be 1 and what? 7 all over 2. So that is the other point. But basically, you can actually use the x and the y intercept. Now, after doing that, then you can now come and draw the what? The graph. So you can come now and draw the graph. So we have -1, -2, -3, -4, -5, -6 there. 1, 2, 3, 4, 5. 1, 2, -3, 1, 2, 3, 4, 5. Okay. So this is x, and this one is y. So where is the point? -6, 0. It is on the what? X-axis, right? So -6, then y is what? 0. So that is the point. Where is the point? 0, 3. 0, 3. It is there. And then we do what? We draw a straight line there. And this is our equation, minus x plus 2y equals to 6. We can actually get the other point. So 1 and 3.5, right? The other one is 1 and 3.5. So 1 and what? 3.5. You see it's somewhere there. Okay. So it is still on the same line. It is on the same line. Any question? Any question? Now, how should we graph this? So let's try this one. Graph y equals to 5x. Graph y equals to 5. How should we graph y equals to 5x? So we look for that. We start by getting that y and the x intercepts. So let's start by solution here. We get the what? The x intercept. So for the x intercept, what do? We let y to be equals to what? 0, right? So we let y to be equals to 0. So when you let y to be equals to 0, then our x equals to 0. So we have the point 0 and what? 0. Also, if we take the y intercept, then we let x to be equals to 0. So our y is also equals to 0. So we have the point 0, 0. So what will you do if you have? Okay. What will you do when you have the 2 points there, 0, 0? So you need to get the other point, right? So you need to get the other point. So the other point you can let, what will you do? You can let x to be what? 1, right? So you can let x to be equals to 1. And our y equals to 5 times what? Which is equals to 5. Our other point will be 1 and what? And 5. Our other point will be 1 and 5. So actually we have already gotten the 2 points. So we have 0, 0 and what? 1, 5. So we can make a straight line there. So you now come here to your graph. So you look for 0, 0 and 0, 0 is there. Okay. And then you look for 1, 5. 1 and what? And 5. 1, 5. And then you do what? You draw a straight line. And this is our graph y equals to 5x. Y equals to 5x. So it is going to that direction, and also that. It's also going that way and that way. Are we together?
So when you get the other point, can you put any number in?
Yeah, you can put any number. So we can say we can put y to be, so you can say y to be 10, right? So you can say let's y equals to 10, okay? And then you just put in there. So 10 equals to, oh, you don't see. So y equals to 10. So you just say 10 equals to 5x. So what will be our x? X equals to 2. What is our coordinate? 2 and what? And 10. So if you come back to this, then you just come and look for 2 and then 10 over there. And then you put the point there. And then you draw the graph. So you can choose any number. You can even choose the negative. So you can say, you can also say x let x to be -1. So you can say let x to be equals to -1. Okay. So when you let x to be equals to -1, then our y equals to negative what? -5. And our point will be -1 and -5. So when you come back here, -1 and -5 is somewhere there. It will still be on the same line. So such a line has many solutions. So the solution of that line is any point on that line. So the solution of this equation, which we will see later, is any point in that line. But now, if we had, I don't want to explain much about it. If we have two equations, this one and this, yeah, but we will see it later. Then if we draw the graph of the two of them, then the point where they meet here is the solution of that, of those equations, is the solution. So if we have the equation x minus x plus 2y plus equals to 6, y equals to 5x. If we draw the graph of the two equations, like the way we have just done here. So the first equation is this, the second equation is this. Where they meet here is the what? Solution. And the solution now will be this point here, which is the x, which you read from here, and the one which you read from here, the value of y. So the value of y which you get from this point, and the value of x which you get from this point, will be the solution of the what? Of that system. So we'll just see it. Don't worry about that. Any question? Okay. What's that? Oh, okay. Oh, I said I will give you some quiz, right? I'll give you anytime, maybe today. I don't know. If we get some time, I'll give you something. Or Friday, maybe Friday, I'll give you some quiz on chapter 2. Okay, so let's come to section 3.23, the slope of a line. So what is the slope of the line? So section 3.28, slope of a line. Slope of a line. Is anyone familiar with it? The slope of the line. So if we have the equation, if we had, okay, I can do this. So if we have that, and then we have, let's say this one is the equation y equals to 5x, okay? And this is x, and this one is y. So the slope of this equation, we can read it from here. So this is the slope of this equation. So the slope of this equation is now the change in x all over the change in y. So the change in y all over the change in x. So to get a slope of this equation, then the change in x all over the change in y. So definition. Slope formula. So what is the slope formula? The slope between the points x1, y1, and x2, y2 is given So we usually write the slope. If we have the 2 points here, we take this one as x1, or we can say x2, y2, and then we take this as x1, y1. So if we have the 2 points on the line, then to get a slope of that line, then the slope of that line will now be m. So we use the m to get a slope is equals to the change in y all over the change in x, which is the same as y2 minus y1 all over x2 minus x1. And this means change in means change. So it matters on how you subtract the 2 coordinates there. So if you're starting from y2 minus y1, then the denominator should be what? x2 minus x1. If you're starting from y1 minus y2, then the denominator should be what? x1 minus x2. Because at some point, the 2 coordinates, one of them can be having the negative. Okay? So if one of them is having the negative and you have interchanged, then it will give you a different result. So do not change this. So if you start from y2 minus y1, then you divide by x2 minus x1. If you start from y1 minus y2, then here should be x1 minus x2. x1 minus x2.
Does it matter which one you start with?
No, it doesn't matter. As long as you're consistent.
Okay.
Yeah. So if you're consistent, then you will be good. Okay. All right. So example. So if we have that kind of a graph, okay. So how can we get this? So we can choose any point. So we can take any point along this line, as long as we are getting, we can get the whole numbers. So we can take here, B and 1, B and then we can get another point, this one, right? 6 and 6 and 1. So we can take 3, so into the that. So we can actually take this point and what? And that point. So, and that way will give us the slope of that line. So we can use this one as x1 or x2, y2. And this x2, y2 is what? What is this point? 3, 3. And then we take this point as x1, y1. And what is this point? 6, 1. That point 6, 1. So our gradient, which is m, equals to change in y all over change in x, which is similar to, we can say y2 minus y1 all over x2 minus what? x1, x2 minus x1. And it is equals to y2 is what? 3. Minus y1 is what? 1. All over x2 is what? 3. Minus y1 is 6. And this is equals to 2 over what? Negative what? So our gradient is equals to negative 2 over 3. So that is our m. So that is our So if your line is going from left to right, it's coming this way. Should be a negative spot. So if you have that one there, and this one is y and this one is x. So if this line is coming this way, then our m is what? Right. And then if the line is going back, then our m is what? Positive. Okay. So if you look at this example, that line is going in that direction. So that means our m is to avoid. Any question? We okay? Good. Now, we have, so let's say, so if you have okay. And then we have this like and you can set this just y equals to 4. So what is the gradient of that line? What is the gradient? So we know that m equals to change in y. What is the change in y? X, right? And you know this one is y2 minus y followed by x2 minus x1. Now, if you look at this line, is there any change in y? No. No, right? So it is only 4. So basically, there is no change in y. Is there any change in x? No.
Yes.
Is there any change in x?
Yes.
Oh, yeah. Sideways. So x is changing, right?
Yeah.
But how about the y? There is no change, right? So it is 0, right? Because it's moving from in the same direction. So there is no change in slope in x. So what is the slope? 0. So there is a change in what? In x. There. So there is a change in x. So therefore, 0 all over this is. So the gradient of this line is 0. Now, if that line is now, if this line is maybe there, if that line is like that, so we know that m equals the change in y or change in x, and we have the change in what? Y is changing, right? So y is changing. But the x is what? 0. So what is this? This is not defined. So that is
there a symbol for undefined? Is it the same one?
yeah, I think it's in your
Still that one.
I think still the empty sign. I think it's I'm not so sure, but I don't know whether it's way and yeah, I think maybe it's so there is no grade. But this one is what? So this is 0 and this is no. So it's undefined. Are we clear for that? Good. Did you write anything there, or you want to write some notes? So you just write it. So it is horizontal. So it's like this. The horizontal. What? Now the question can be, use the formula. Use the formula to find the slope of the point Q minus T. So we can actually say this is x1. Our formula is M equals to change in y followed by change in x equals to y to followed by x2 minus x. This is equals to. So you should always be considerate on the what? The same. So y2 is 4 minus y1 is what? Minus 1. All over x2 is what? Minus 7. Minus 2. And that is equal to. So 4 minus 3 is 4 plus 3. All over minus 7 plus 1. And this is equal to 7 over. So our gradient is negative 1. Any question after that? So that is how we get the slope of a line. Slope of the line. Slope of the line. Hey, so you can try this. Six and minus 3. What is the slope of that line? What is the slope of that line? So just the same thing. That's one. Change it and change it. Also, y2 minus y2 is minus 4 minus 6 all over minus 3 minus and this is the same as minus 4 all over minus, because this is minus 3 minus 2 is 3 minus 3 plus 2, which is minus 1. And this is equal to what?
That's our slope.
Yeah, that's what it's like.
You
10
don't
over
have to
1.
graph it every time.
So you don't have to graph it. So you can, the question is use the slope. The slope formula is M equals to change in y all over change in 1 is equals to y2 minus y1 all over x2 minus x. So that is the slope formula. Any question? Very, very good. Okay. So there is something else which there is an interval. These are always common in mathematics. So the question can be find the interval notation and the algebraic notation. So x, let's say x. What was the last example that we said on the isolates inequality? Let's say this one. X minus 5 less than 1. Let's say less than 0. Okay. So find the solution of this. You can graph it and then write the interval notation as algebraic notation. So what did we say about this? If this one is less than, then this one is 1. Okay. So therefore, x minus 5 is greater than 0, or x minus 5 is less than. Sorry. So this is x is greater than 1, right? And x is less than 1, right? X is less than. Is this right? It is not. So we can put something here, like what did we put 0?
Mhm.
So okay. So basically, we now say x there can be greater than 5. Yeah. And x here can be also less than x can be less than 5. So I wanted to explain something with interval notation and algebraic. So this is what we call algebraic. For the interval notation now, this and one. So it will now be parentheses, right? 5 and 1. This is now the interval. So this is the algebraic. So if you write x less than or equal to 5 or minus 5, x less than or equal to 5. This is the algebraic. Minus 5 that way, 5 that way is what? Interval. Any question? We still have like how many minutes? 4 minutes. Any question on what we have done? Now, before we go, how can we what is the, can you try graph? Oh, 3x minus 4y equal to minus 12. Using x and y is the x and y. So what do you do? So when x is percent, y is equal to 0. So when y is 0, then x is equal to what? Negative what? So our coordinate here is -4 and what? Okay. When y equals to y intercept, this is where x equals to 0. So what is our y? Y equals to what? 3, right? Y equals to 3. And our coordinate is what? 0, 3, 0, 3. Then you do what? You plot that straight. Plot it straight. Okay, so if you don't have any other question, then we can be for Friday. Make sure you do your work. Okay, so there is no.
Some of the answers, you know, how you just put it's negative in your, was that only if they like cross each other, like these two would go in, or this one went that way?
Yeah, so this one is this one is
That's right.
Yeah,
Right.
and
so
this one
it's
is
just
only
like-
so it will just
And if like, say this one is going negative and this one's going positive, then we can write out
yes,
both.
yes, that's
Right, okay.
And those are count, yeah.
So when I-
Right, if they don't touch each
Yeah,
other. Okay, yeah, thank you.
Real quick. So I was looking at the homework